Here we're going to solve a couple of equations that contain square roots, and in each case the equations will contain only one square root. Alright, the first thing you want to think about when solving a square root equation is get the root isolated on one side of the equation and then square both sides of the equation. This root's already isolated, so we don't have to move anything around. We can go right to squaring both sides of the equation. Now when I square both sides of the equation, the root and the square are undoing each other and we get the insides out of the root. We get 3x plus 4, and that equals 8 squared or 64. Now if that looks a little bit strange, think of it this way. Instead of root 3x plus 4, let's say we had just root 3. And let's say we square root 3. If we square root 3, that's the same as root 3 times root 3, which is the same as the square root of 3 times 3, or square root of 9. And the square root of 9 is 3. So you can see that when you square a square root, you get the insides, the 3, out as your result. So that's why the result here is 3x plus 4. And now we have a linear equation, so let's go ahead and solve for x. Subtract 4 on both sides and we get 3x is equal to 60. And dividing by 3, we get x is equal to 20. So we have a solution, but when you're doing square root equations, always check that your solution works when you put it back into the original equation. And the reason why you always want to check that is because sometimes you can do the math steps all correctly and you're going to get a solution, but the solution will not work in the original equation. It's a false solution, or what's called an extraneous solution. So let's go ahead and check that out. So if we put x is 20 into the original equation was root 3x plus 4 is equal to 8. So we want to see, does the root 3 times 20 plus 4 equal 8? And if it does, our solution is a valid solution. And that would be 60 plus 4, so that's root 64. Does that equal 8? And yes, it does. That means our solution checks out, and yes, x equals 20. Now if it seems strange that you might get a solution that doesn't work, even though you do the math steps correctly, think of this equation instead. If we had square root of x is equal to negative 2, if I square both sides, I get square root of x squared equals negative 2 squared. And if I have the square of a square root, I get the insides out. X is equal to negative 2 squared would be 4. Now if I look back up here, the square root of x can never equal a negative number, but suddenly going through the math steps I got an answer of x equals 4. And if we put the x is 4 in here, we'll see it doesn't work. It doesn't equal negative 2, it would equal 2. Alright, so that's an extraneous solution. But in our equation the 20 worked out. Now this next equation does have an example of an extraneous solution. Square root of 2x minus 1 plus 2 is equal to x. The first thing we have to do is isolate the root, because we don't want to square both sides until it's isolated. If we square both sides right now, we're going to have the square root of 2x minus 1 plus 2 times itself, and we're going to have to FOIL it out, and we'll get a huge mess of stuff. So first we need to isolate the root. So we get root 2x minus 1 is equal to x minus 2. And now that the root's isolated, we can do the step of squaring both sides. And when we do that step with an isolated root, that's when we get the insides out. So the x was buried inside a root symbol, but now we've taken it out from the root, so we'll be able to solve for x. So we have 2x minus 1 is equal to x minus 2 squared, which is x minus 2 times x minus 2. And let's multiply out the right side. So we have 2x minus 1 is equal to x squared, and minus 2x minus 2x will give us minus 4x, and minus 2 is plus 4. And here we have a decision to make, right? Because we want to solve for x, and we have to ask ourselves, Are we going to solve a linear equation, which means isolate x on one side of the equation, or are we going to use the quadratic equation approach? Is it an x squared equation? Now this is an x squared equation, so what I'm going to do is try to solve it by factoring, because that's the easiest method, so let's see if that works. So to solve by factoring, we want equals 0 format. Get everything on one side of the equation. So we'll start by adding 1 to both sides, and that gives 2x is equal to x squared minus 4x plus 5. And now we'll subtract 2x from both sides, because we want to have just a 0 on one side of the equation. 0 is equal to x squared minus 6x plus 5. And now we can try to factor. And this is factorable, so that's good. That means we'll be able to solve for x. So we have x times x, and then 5 and 1. And because it's plus 5, we need same signs. And because the same signs combine to a negative 6, we need them to be minus signs. So now we have either x minus 5 equals 0 or x minus 1 equals 0. Because in either case, if one of them equals 0 and they multiply together, then the product will be 0. So x equals 5 or x minus 1 equals 0, which would be x is equal to 1. So we have two solutions here. Now sometimes both solutions are going to check out and be fine. Sometimes one of them will, sometimes neither of them will. So we have to check both solutions. And let's see what happens here. X equals 5 and x equals 1. Back into the original equation. Root 2x minus 1 plus 2 equals x. So let's start with the x equals 5. Does the root of 2 times 5 minus 1 plus 2 equal 5? And this is 10 minus 1, or root 9. Does root 9 plus 2 equal 5? And that would be 3 plus 2. And yes, that equals 5. That means x equals 5 is a good solution, or a valid solution. And we're going to do the same with the x equals 1. Root 2x minus 1 plus 2 equals x. And the question is, does root 2 times 1 minus 1 plus 2, does that equal 1? And let's see, 2 times 1 is 2, minus 1 is 1. So root 1 plus 2, does that equal 1? And that would be 1 plus 2. Does it equal 1? Well, this is 3, which does not equal 1, which means x equals 1 is an extraneous solution. We're not going to include it as part of our answer. Final answer is x equals 5.